Students, whatever homework is given to you, you have to submit it on the very next day between 8 am to 1 pm to the given WhatsApp number, and it is compulsory to submit your homework as your attendance will be marked on the basis of your submission.
Good morning, students. Today we are going to start with a new chapter, that is triangles. The last year also you have learned about triangles. What you have learned? You have learned how the triangles to be congruent. Then you have learned so many theorems and postulates related to that congruence of two triangles. When you can say that two triangles to be congruent, when its corresponding sides are equal and corresponding angles are equal, then you can say that triangles are congruent. In this chapter, we are going to see about similar triangles. Similar. So you may be knowing that what you mean by similar. Sometimes you may say that twins, identical twins, they look like similar. Like that we were saying. Similar means what is that? Same shape. Is it right? The geometrical figures. In the case of similar figures, we can say that two geometric figures having same shape and size, they are called by the name congruent to each other. Is it right? Two line segments, if they are having same length. Is it right? Suppose this is also 5 centimeter, this is also 5 centimeter. So you can say that these line segments are congruent. That means the figures which are having same size and shape, they are called congruent figures. Now similar figures means what is that? Two figures, geometric figures which are having same shape only. No, the size are not same. Okay, that is called by the name similar figures. So here we are going to see about can you say that two triangles and two polygons, how can you say that it is similar? So here if I am drawing two line segments, one is AB of 5 centimeter, other one is PQ of 2 centimeter. So these both look like similar. Why it is so? Because they both are having the same shape. Is it right? Or we can say that whether size are not same, but we can say that AB and PQ are similar. Same way, two triangles. I have drawn here two triangles, and these two triangles look like similar only because both are having the same shape. These two circles, then also we can say that they are similar. And when you can say that two circles are congruent, when you will say that when their radius are same. Is it right? Two circles which are having the same radius. That means two circles I have drawn having the same radius. That means this is also 3 centimeter. If this is also 3 centimeter, so we can say that circles are congruent. But when you say that similar, the shapes are same, but radius are different. Like this way you can also write, like this way also. These both look like similar only. See, these are similar figures. Same way, two rectangles, they are also similar. Why? Because their shape is same. Now, two congruent figures are similar. Congruent figures are always will be similar only, but two similar figures may or may not be regular. That means that may not be congruent. Two similar figures may or may not be congruent. That means there are possibilities are there. Sometimes it may be congruent, but sometimes it may not be congruent. But definitely we can say that all the congruent figures, suppose these two circles I have drawn, they are congruent. We can say that they are similar also, because we have to need only one condition, that the shape should be same. Then we can say that they are similar figures. Now you might have understood like this topic, what you mean by similar. Congruent is different than the similar. Now the last chapter you have learned, previous section, previous class, you have learned 9th standard. You have learned about the congruent triangles. Here also we have to, how can you say that two triangles to be similar? Is it right? Now for that purpose, there should be some conditions. What are the conditions for that? They said congruent triangles, we have seen that all the corresponding sides are congruent and all the corresponding angles are congruent. Then you can say that the triangles are congruent. And the congruent sign also you are writing like this way. Is it right? This is the way you are writing. Congruent symbol. Is it right? That means triangle ABC is congruent to triangle PQR like that. But here similarity, in the case of similarity, what are the special conditions satisfy. So here we can see that I have drawn two triangles. Okay, two triangles like this way. But you cannot say that they look like same. That means they are similar. Maybe look, but there is no special case. That means it cannot be said that whether it is similar or not, because some more condition to be satisfied for this. By shape you can say that they are similar, but it may be true or may not be true. So that case we should need some important characteristics for making two triangles to be similar. First we will consider about any polygon. Polygon means you know that having number of sides more than 3. That means that is called polygon. So here we can say that triangle, square or quadrilateral, pentagon, hexagon, like that, any polygon. So when you can say that the polygons are similar. Understood? The polygons are similar. How can you say that? When that polygons, all the corresponding angles. For example, I have drawn here two rectangles. Okay, so you know that this rectangle, all angles are 90 degree. Another rectangle, I have drawn here that PQRS. Here also, you know that being a rectangle, all angles are congruent. Corresponding angles are congruent. But now you have to look at whether it's a sides ratio. That means if I written here 6 and 2. Okay, and this figure I have written here 1 and 3. Look, 6 upon 3 is equal to 1 by 2. 6 upon 3 and 2 upon 2. 6 upon 3 is equal to 2. 2 upon 1 is also equal to 2. That means all the corresponding sides are also in the same proportion. Then only you can say that these two polygons are similar. Understood? Whether by looking at the size, we cannot say that, sorry, it's a shape, we cannot say that they look like similar. Why it is so? Because you know that when you are taking a passport size photograph, the measurements are equal for all the cases. The passport size photograph at the age of 16 you are taking, and at the age of 70 also you are taking. Both the cases, the size is same. Is it right? That means the shape of that card is same, but they are not similar because the different faces are going to see in that. So that means you cannot say that their passport size photographs are similar. But you know that sometimes you are taking the photographs, passport size photographs, suppose 16-year child, your age, one child is taking a photograph. It can be passport size, it can be stamp size, it can be a large type for that size. But that may look like similar. That all photographs look similar. Why it is so? Because the first topic or the first photo, whatever the picture is there, the same picture is showing in the second size also. That means size are same as well as shape are also same. Size are different but shapes are same. That case we can say that they are similar. So here we are saying that for two polygons to be similar, what is the condition? That the corresponding sides should be proportional as well as corresponding angle should be congruent. Any kind of polygon, whether it will be of 5 sides, 6 sides, 7 sides, whatever it is that. So this condition is applicable for all the polygons. So when you can say that the polygons are to be similar, its corresponding angle should be congruent and corresponding sides are proportional. So now you may have understood that what do you mean by similar figures. Okay, so similar figures and congruent figures both are different only. Congruent figures means size and shape are same. Similar figures only shape are same. Size can be varied but size should be proportional. Now two congruent figures are always similar, but two similar figures may or may not be congruent. Now let us move to that exercise. Now you might have understood that clearly what do you mean by similar figures. Now come to exercise 6.1. So you might have got the idea about similar figures. In that you can say that triangle and rectangle can never be similar because they are different shapes. Now two polygons, I already mentioned to you that same number of sides are similar if the corresponding angles are equal and the corresponding sides are in proportion. So when you can say that two figures are congruent, examples, two squares of same length, here two rectangles of same dimension, here two equilateral triangles of same length, here have two circles of same radius. This you can say that they are all congruent figures, not similar. Okay. Now, triangle and rectangle can never be similar. That means two different shapes are coming. So we can say that it will not be similar. Now, you clearly understood what is the what do you mean by similar figures. Now look at the exercise 6.1. First question is that fill in the blanks. All circles are, in bracket it is given that congruent or similar. So we know that all circles are similar. Maybe it having different sizes. Sizes means that this radius can be changed. Now second question, all squares are dashed. Squares are also similar. Now all dashed triangles are similar. Which type of triangles are similar? All equilateral triangles. That means having different measures. Equilateral triangle means you know that having all the sides are equal. Now fourth question, it is that two polygons of the same number of sides are similar. If their corresponding angles are dashed, their corresponding sides are dashed. What is that? It's already written here that two polygons same number are similar, corresponding angles are equal, and corresponding side how should be there are in proportion. Now second question is that if two different examples of pairs of similar figures. So which are the similar figures? We can say that two circles of different radii, they are of similar figures. Two squares of different measurements, different sides. That means one square is having 5 cm, one square is already having 3 cm. We can say that they both are similar. Like that way you can write down so many examples. Second question is that two non-similar figures. Already I have written here that triangle and rectangle can never be similar. Or square and rhombus, that is also not similar. Why it is so? Because square all the corresponding angles are 90. So it may be vary in the rhombus. So this both conditions should be satisfied. Corresponding angles equal, corresponding sides are in proportion. Whether the sides are coming, then also we can not say that because angles are not equal. Suppose I written here this square, all sides are suppose 4. And this case we can say another one rhombus, its sides are also 4. But what is the condition not satisfied here? Corresponding angles are congruent and condition not satisfied. Therefore these are not similar figures. Now similarity, how can you say? How can you denote? Similarity, that means we will write down like this way for congruency. So sirf E, that means this one. This one is for the similar notation. Similarity to write down, that is a notation for similarity. Now third question, there is a question is given that state whether the following quadrilaterals are similar or not. That means here two figure is given that both are of quadrilateral but their measurements are given like this way. One is PQRS or size is given that 1.5, that means by looking at this you can say that is a rhombus, and other one is a rectangle. This one already I mentioned to you before that also. That is ABCD, sides are 3. So when you are saying the corresponding sides ratio 1.5 upon 3, 1.5 upon 3, 1.5 upon 3, 1.5 upon 3, that is correct. But what is different here? Corresponding angles are not equal. Here all angles are 90 degree. Here it is not given that angles. That means that is varying. By looking at this you know that it's a rhombus. All the angles are not equal. Now here by looking at the figure we can say that these two triangles are these two are not similar. These two quadrilaterals are not similar. Clear for you children? Now next topic is that we are going to see about, how can you say this about normal polygons, about the polygons we are saying, whether it is a quadrilateral, whether it is a pentagon, whether it is hexagon, like that. Now the next what you are going to see special about the similarity of the triangles. Now you are going to see about the similarity of two triangles. Polygons, about polygons you already learned that. Now similarity of triangles. How can you say that two triangles to be similar? The condition is same only. What is that? Corresponding angles are congruent and corresponding sides are in proportion. That means for a polygon, whatever we have learned, same thing will apply for the triangle similarity also. That means if two triangles are given, ABC and PQR. So while looking at this, you say that similar, but it may or may not be. So some condition to be satisfied for that, which are the conditions that all the corresponding angles, that means A is corresponding to B is corresponding to Q in this figure or in this correspondence, and C is corresponding to R. So angle A should be equal to P, B should be equal to Q, C should be equal to R. Same time, other condition what it should satisfy, line segment AB upon PQ, that means its length AB upon PQ and BC upon QR and AC upon PR should be equal. So we can say that triangle is similar. So I can say, I told you that this is a symbol for the similarity. Okay, so triangle ABC is similar to triangle PQR. Now we understood that what are the conditions for making two triangles to be similar. And this chapter related to this similarity, we are going to see another theorem. What is that? Basic proportionality theorem. Otherwise, it will be known by the name Thales theorem. Okay, both are representing the same only. What is the theorem statement that if a line is drawn in parallel to one side of the triangle, if a line, in triangle ABC, one line I have drawn parallel to which side I have drawn BC. Okay, one line is drawn parallel to one side of the triangle. It definitely intersects the other two sides. How many points? Two distinct points, which is intersected at P as well as at Q. Then what is told that the two sides are divided in the ratio, same ratio. That means AP and PB. Whatever the ratio is forming, AQ and QC also will form the same ratio. That means AP upon PB is equal to AQ upon QC. This is the theorem, basic proportionality theorem. And this theorem's statement only you have to learn now, because due to these online classes and COVID-19 situations, this board itself cancelled the proof of this theorem. That means basic proportionality theorem statement only. Sometimes it may be asked, what is basic proportionality theorem? If a line is drawn parallel to one side of the triangle, intersects the other two sides in distinct point, the other two sides are divided in the same ratio. That means we can say that AP upon PB is equal to AQ upon QC. This is the main result you have got from the basic proportionality theorem. Now, two more results you can derive from here, that is using the properties of the ratios. We are going to get other two ratios are also AP upon AB is equal to AQ upon AC. That means a full distance. AP upon AB is equal to AQ upon AC. Yeah, PB upon AB is equal to QC upon AC. This is also we can use in our sums. These are the two results derived from this data only. Okay? The other two results is derived from this result only. This is the basic result. From that, using the ratios properties, we are trying to do more ratios like this way. And using this basic proportionality theorem, some sums are there in your textbook, exercise 6.2. So what is similarity you might have understood, what is basic proportionality theorem also you might have understood. Now let us move on to the exercise 6.2. Now move on to exercise 6.2. That's based on the basic proportionality theorem. That already we have discussed that what is basic proportionality theorem, etc. Now exercise 6.2, one figure was given here that triangle ABC is given that line DE is parallel to line segment BC. Now some of the measurements are also given. AD is given, DB is given, A is given, but EC is not given. So according to basic proportionality theorem, these two are parallel. So what you can say that AD upon DB is equal to AE upon EC. So we can say that AD upon DB 1.5 upon 3 is equal to 1 upon AC. Cross multiply, we will get the AC value as 2. Same way, question number 2 is also given there, that find AD. That means a triangle ABC is given, line segment DE and line segment BC are parallel. Again, you can apply the basic proportionality theorem. So you will get that AD upon DB is equal to AE upon EC. So here AD upon DB is given that 7.2, AE is given that 1.8, or EC is given that 5.4. Now cross multiply, we will get the answer 2.5. According to the basic proportionality theorem, you have completed both the sums. Now second question, what is telling that suppose these ratios are, that means converse of basic proportionality theorem is also there. Converse means that means there we have learned that if a line is parallel to one side of the triangle, if it intersects the other two sides in two distinct points, according to basic proportionality theorem, you have a complete rectangle. According to basic proportionality theorem, you have completed both the sums. Now second question, what is telling that suppose this ratios are, that means converse of basic proportionality theorem is also there. Converse means that means there we have learned that if a line is parallel to one side of the triangle, if it intersects the other two sides in two distinct points, Now, if the ratios are equal, that means AP upon PB and AQ upon QC, the ratios you are going to get equal, then you can say that this line is parallel to the third side. Okay? One line which intersects the two sides in two distinct points, such a way that the ratios are equal. So what you can say about the line? The line is parallel to the third side. This is the converse of basic proportionality theorem. Now, using that converse of basic proportionality theorem, question number 2 of your textbook exercise 6.2, there is one E and F are on the points on the sides PQ and PR of a triangle PQR, but it is not given that this line is parallel. I have just drawn like that way, but it is not given that this line is parallel or not. This line parallel, you have to find out. How you will find out? You will take the ratios. So right, which ratios you will take? 3.9 upon 3 and 3.6 upon 2.4. Whether these ratios are equal, so we can say that this is parallel to this one. So by the concept, we know that this one 1.3 you are going to get, this one some other value you are going to get. That means the ratios are not equal. So according to the converse of basic proportionality theorem, you can say that this line is not parallel to this one. Okay, this is the application of the converse of basic proportionality theorem. So here you apply the basic proportionality theorem and find out the values, because here already it was given that line is parallel to the third side. But here the line is parallel or not, you have to find out. For that purpose, we apply the converse of basic proportionality theorem. So two more sums are there in that. Only one sum I did it here. Two more sums of questions are there that you can do yourself. Okay. Now till this exercise you have to complete in your notebook. So whatever the questions are going to come for the examination, that only I am going to do in the classroom. Others are exempted from the